Hey guys, just me, Mr. Plazik. We just got finished talking a little bit about epithelial tissue. Now we're going to move into the most abundant tissue in your whole entire body, and that is connective tissue. Connective tissue joins other tissues together. It also has a protective property, a support property as well. So this is the most abundant type of tissue in the whole entire body, and that is going to be connective tissue. And this tends to be a little bit one of more of the difficult tissue types to kind of grasp. So I'm going to go kind of slow when I start out, and then we'll move into diagrams and then the diagrams and pictures of the actual tissues themselves as far as connective tissue is concerned. So if you remember earlier, we talked a little bit about epithelial tissue. And when I took a look at epithelial tissue, it basically was a group of cells that were all tightly joined together is what epithelial tissue looked like. So epithelial tissue was a cell here, a cell here, a cell here, a cell here. But these cells were tightly joined together when I looked at epithelial tissue. Okay, connective tissue is the complete opposite. So when I look at connective tissue, the cells are more spread out. So I might have, with connective tissue, I might have a cell here, a cell here, a cell here, a cell here, and a cell here. So there's space in between the cells, and this space in between the cell is where we find this what we call extracellular fluid, okay? Or this, not extracellular fluid, I'm sorry, this extracellular matrix. So this is the extracellular matrix, is this space that's in between the actual cells themselves. So this is called the extracellular matrix itself. All this space that's in between these cells right here is the extracellular matrix when I take a look at this connective tissue itself. So connective tissue, the cells are more spread out, and it has this extracellular matrix. And this extracellular matrix consists of two different substances. There's the ground substance, and then there's fibers. And these two different ground substances and these fibers are going to make this particular connective tissue that we're looking at really unique. If I have like a lot of elastin fibers in there, this connective tissue is going to be really stretchable. If the ground substance has a lot of water that's associated with it, then the actual connective tissue is going to have more of a fluid like matrix that's associated with it. So this is a broad variety of tissue types when I take a look at or categories that kind of or tissues that fall into this connective tissue category, from blood to bone to tendons to ligaments. All these are different types of connective tissue that we're going to take a look at when we look at connective tissue in this particular lecture itself. So connective tissue, like we said earlier, is found everywhere in the body. It includes the most abundant and widely distributed tissue type that we have. Its major functions is it's going to bind other body tissues together. It's going to support the body. It's going to provide protection. We see this binding of other tissue together when we think about tendons and ligaments. Remember, these ligaments are going to join to bone, tendons are going to join muscle to bone. When we take a look at areolar tissue, it's going to help bind skin or other organs, tissues to other organ tissues. It kind of looks like a spider web. The support that we can see with the connective tissue is kind of with the bone. Bone's a connective tissue, and you know the support that it provides the body. Also, connective tissue is also going to provide protection. Bone is another example of providing this particular type of protection itself. It protects the actual brain. It protects the spinal cord. We look at blood for protective purposes. Think about when blood is going to protect us because it can prevent us from bleeding to death because it has this clotting capacity. It also dries out and forms a scab over an area of injured skin. Connective tissue has a variety of characteristics. It's going to have variations in blood supply, from having really good blood supply to it to some types of epithelial tissue have no blood supply or limited blood supply to it at all. The key characteristics of connective tissue is it has this extracellular matrix that I talked about earlier. This is the non-living material that surrounds the living cells. So you have these living cells, and then you have this extracellular matrix that's going to surround the cells themselves. And this extracellular matrix is composed of two components that make it up. The first component that we have is a ground substance. The ground substance is mostly going to be water, along with adhesion proteins, polysaccharide molecules as well. So you have some water, you have some proteins, you have some carbohydrates, or these simple sugars or these complex sugars that are in there as well. The more water that I have, the more fluid that my connective tissue is going to be. Also with the ground substances, we have fibers, and these fibers are going to be produced by the cells, and they're going to throw out this production of what they're producing into the extracellular matrix. There's three basic types of fibers that we have. We have collagen fibers that provide strength. We have elastic fibers that are going to provide this stretchability. And then we have reticular fibers that are going to provide structure as well. So you have collagen fibers, elastic fibers, and reticular fibers are the three types of fibers that we find along with the ground substance. So this extracellular matrix is a non-living matrix that surrounds the cells themselves. There's two components to it. There's a ground substance, and then there's these fibers that we have. The first type of connective tissue that we're going to take a look at is bone tissue. Now, when we look at bone tissue, basically it's a hard matrix. So the matrix that's surrounding the cells themselves are mostly made of what we call calcium salts. There's also the fibers that are going to be present there is going to be collagen fibers. The function of bone tissue is going to protect and support the body. When we take a look at bone tissue underneath the microscope, it has this distinct ring-like structures that are associated with it. We have these structures called lacuna, lamella, these types of things. We'll talk about these a little bit later when we get into the skeletal system. These little radiating things are called canaliculi. You guys don't have to know that yet. You just have to know bone is a particular type of connective tissue that the extracellular matrix consists of calcium salts, and then the fibers that are going to be in there is going to be the collagen fibers are going to be associated with it. This is a real easy one to identify underneath the microscope itself because it kind of looks like rings of a tree when you take a look at it, but this is bone tissue. Another type of connective tissue that we have is cartilage, and there's three main types of cartilage that we have. We have hyaline cartilage, we have fibrocartilage, and we have elastin cartilage. Hyaline cartilage is going to be the most common type of cartilage that's found in your body. It has a rubbery matrix that's associated with it. It has collagen fibers is the major fiber type that is in the hyaline cartilage. We find this at the ends of our bones. So we take a look at the ends of the bones and we notice it has that real slippy surface. That's hyaline cartilage. You may have gone to a place that serves wings. At the ends of wings, you notice there's cartilage on there. You may have chewed on that cartilage. That cartilage that you're chewing on is hyaline cartilage. We also find this in our larynx. And also the entire fetal skeleton is composed of hyaline cartilage, and then it becomes ossified and becomes more bone-like as you grow and as you develop. So that is your hyaline cartilage. This is what it kind of looks like when we take a look at it. And you can see here it's at the ends of our bones themselves. This is the ends of our ribs connecting to the sternum. The other two types of cartilage that we have is elastic cartilage. We find elastic cartilage like in our ears, okay, at the ends of our nose. It has this real elasticity that's associated with it. And then in between our vertebrae, we have another type of cartilage is called fibrocartilage. It's highly compressible. It can withstand shock and things like that. So that is fibrocartilage that we find in between each of our vertebrae. And then elastic cartilage we find inside of our ears, and then in our nose as well we find this elastic cartilage that has extreme bendability that's associated with it. This is just a microscopic picture of what fibrocartilage looks like. The next type of connective tissue we're going to take a look at is called dense connective tissue. Now we have dense connective tissue and we have loose connective tissue. Dense connective tissue, the fibers are kind of all aligned together and they're tightly compacted to one another. The major matrix that we find in dense connective tissue is collagen fibers. You have these specific cells called fibroblast cells, and these are the cells that are going to make these collagen fibers themselves. Where we find dense connective tissue, often we find it associated with tendons, ligaments, and then the dermis. Tendons are going to attach skeletal muscle to bone. Ligaments are going to connect bone to bone. And then the dermis is going to be the lower layer of your skin. If you guys have leather shoes on, that's actually dermis that you're taking a look at. And that's going to connect the lower layers of your skin together is what the dermis is going to do. But this is the dense connective tissue. It has a characteristic look to it. This is an example here of I think we're looking at a tendon here, and you can see these are the cells right here, and then these are the fibers that are embedded outside the cells. But you can see the fibers are real densely put together when we take a look at them. So just remember, a ligament is going to join bone to bone. A tendon is going to join muscle to bone. And this is this dense connective tissue. The opposite of dense connective tissue is loose connective tissue. And loose connective tissue, the cells, you can see the fibers a lot easier in the loose connective tissue a lot of the time. And then with the loose connective tissue, the fibers aren't put together in a dense-like manner when we take a look at them. So they're kind of more free, more spread out when we look at the fibers. One of my favorite types of connective tissue is areolar tissue. It's a loose connective tissue. It's the most widely distributed connective tissue in the body. It's soft, it's pliable. It kind of looks like a cobweb. And this is a major packing tissue inside of your body, is where we actually find this. And when we take a look at the rat, when we do the rat dissection a little bit later, you'll peel back the skin, and underneath there you're going to see this like cobweb type of tissue, and that's the areolar tissue that we're taking a look at. It has all different fiber types that are located in it. This is what it kind of looks like right here. This is deep in your skin. We take a look at the dermis itself, and you can see here's the cells, and you can see all these kind of fibers that are surrounding these cells. The cells themselves look like the little spiders, and then the fibers kind of look like the webbing that's there. But this is areolar tissue. The next loose connective tissue that we have is called adipose tissue. Basically, we have flat globules that we have. So the matrix is going to have this fat that's going to be around it, and then the cells themselves are going to contain this large lipid deposits in them. The major function of adipose tissue is going to be to insulate the body. It's going to help protect some organs, particularly organs of the abdominal pelvic cavity that are not housed in bone or not protected by bone. It also serves as a major fuel storage area. So after we've gone through our sugar reserves in our body, then we begin to tap into fat itself. Babies have a particular type of fat that we don't have that's called brown fat that helps insulate them. We don't have that brown type of fat. It's long since gone away after we've gone out of that baby stage of our life. This is what adipose tissue looks like. That you can see, but you can see these fat droplets are inside the cells themselves, and we take a look at, and then these cells become so engulfed with this particular droplet of fat or oil that the nuclei get kicked towards the outside of the cell. The nuclei kind of get kicked towards the outside of the cell, but basically this cell is just going to be loaded with a fatty type deposit that's going to be there. This would be like underneath your skin. Where we would find this fat-like deposit or this adipose tissue. Real easy to identify underneath the microscope. Another type of loose connective tissue that we have is reticular connective tissue. And reticular has these reticular fibers that are associated with it. We find this reticular connective tissue is often associated with the stroma, the inner support network of our lymphatic system or our lymph node organs. Like the spleen, our lymph nodes. We also find it inside the bone, in bone marrow is where we're going to find this reticular connective tissue. And you can see these are this would be in your spleen. You have the white blood cells that are here, and then you have these reticular fibers. These reticular fibers often, to me, look like roots of a tree when you take a look at the reticular fibers. But that is another type of loose connective tissue that we have of the reticular connective tissue that we have there. The next type of connective tissue that we have is going to be the blood. And blood, its extracellular matrix is fluid, and it's called plasma. So the extracellular matrix of blood is called plasma. Blood does have fibers that are associated with it. You really only see these fibers are visible when clotting is occurring. So when our blood clots, it's covering up that area with these fibers, so not all the red blood cells escape. Major function of your blood is going to be a transport vehicle for materials throughout your body. This is what blood looks like underneath the microscope. The plasma would be this white part that's in between here. These are white blood cells, these large cells. These smaller cells are red blood cells. So you have your white blood cells, your red blood cells, and you have your plasma that makes up the actual matrix itself. So that's the basics of connective tissue. Remember, connective tissue is a group of cells surrounded by an extracellular matrix. The extracellular matrix consists of a ground substance. It consists of fibers. These different types of connective tissue vary in blood supply that we talked about, and then we moved into the different types of connective tissue that we have throughout the body. Remember, connective tissue is the most widely distributed tissue throughout the body.